So again, it's time now. Let's have a look at inequalities. This is going to be very basic as a presentation, as I'm going to do it and type it whilst I'm talking to you. So it'll be more like, an unprepared classroom set of things. So what we've got to look at is we've got to look at inequalities, and particularly how we solve inequalities. Hopefully you'll remember some of the notation. Here on this screen we can put in this sign, and we can put in this sign and these signs. These are your principal signs here for your notation. Obviously this one, if we read from left to right, this one would read this side is less than or equal to. The bar underneath means equal to, so less than or equal to what's on that side. This side is greater than or equal to on that side. This one would mean less than, this one would mean greater than. Hopefully that's all quite straightforward, and that we don't really need to go through a lot of that sort of stuff. Why we use inequalities? We use inequalities because it gives us a range of answers rather than a single answer. So for example, if I start off with the equation 2x plus 7, now instead of having equals, if I say that that's going to be less than or equal to, let's make it 15, then what I need to do is need to solve this like it was a normal equation. So less than or equal to 15 minus 7. Just get ahead of myself. So 2x will be less than or equal to 8. And so x is less than or equal to 2. So what this shows then is that I can get a range of answers. Let's just put a note that this is one of our examples. Okay, now this can obviously then be measured on a line. Okay, if we put a mark here, say that's where 2 is, and we'll put a mark here saying that's where 0 is, just so we know which way we're going. Then what we can do is put a line together on this. We're saying it's less than or equal to 2, so I start off here at 2, and I can draw a line down that way. Now, a couple of things need to happen. Let's have a look. We need to change some of the properties of this line, because at that end, at the, depends what it picks out as being the end. Let's make that an arrow, and this needs to be a closed circle. Right, so it's just, so we flip it around. Sorry, just sometimes it's confusing over which side is the start and the end. So you can see here, I've got an arrow at one end which shows that it's continuous, it's continuing on in that direction. Now I've got a closed-in circle because it will use the sign less than or equal to. When it can be equal to that number, then we use a closed-in circle. So if I solve something like this, 3x minus 10, now I'm going to use greater than 5, so that 3x is greater than 15, so 3x is greater than, x is greater than 5. Okay, and again we can draw this on our line. And a lot of the times all we need to really do is to have a look and see where the numbers relate, particularly where 0 is. We don't need to be completely accurate at this point. We're not testing whether you can draw a line to scale. So it says 5, so I go to 5, it's greater than, so it must be in that direction. Now this is where it gets a little bit tricky. is I'm going to have to do a little circle and make sure that it's open, because the line goes to 5 but doesn't actually equal 5. So just highlight that and move that more directly over 5. So we can see then the line says it goes right up to 5, but when it reaches 5, that's when it's not equal to. And if I put a little arrow at the other end, just to show that it's continuing on like that. And so that would be that equation. Okay. Now, sometimes we might get a pair of equations, and we have to satisfy both. So this can generally come in two sort of forms, but we're going to deal with it in one particular form. So, for example, let's say 3x minus 11 has to be less than, let's put a value of 20. No, put 19. And if we use another value,